MCP, or Model Context Protocol, is often described as the USB-C port of AI applications. It was introduced last year by Anthropic, and since then it has quietly become very popular in the AI ecosystem. You might have seen AI agents connecting to dozens of third-party systems, companies announcing their own MCP servers, or maybe even your own engineering team mentioning how MCP is opening up new possibilities. So this video is for product managers who want a simple, clear understanding of what MCP is, why it was needed, and how it impacts you as a product manager. Now, before we talk about MCP, let's quickly revisit how LLMs work. LLMs are very good at generating responses based on your query. So they'll take your query as an input, and based upon the training data, LLMs have been trained to generate the output for your query. Now, they're simply predicting the next most likely token based on the patterns they are learning during training. So, if you ask something like rephrase this email and make it sound more professional, and you also provide the email that you want to be rephrased, the model will give you a perfectly good answer because it has seen millions of such examples during training. But if you ask what's the score in yesterday's India-Pakistan match, that's real-time information or near real-time information, right? So in this case, the model was not trained on that, and it has no way of knowing unless it fetches the data from some external system. Like in this case, it could be ClickBuzz or something. And LLMs cannot do that on their own. This is where the need for something more than just an LLM becomes clear. Enter AI agents. AI agents combine three things. First is the intelligence of the LLM. Second, the ability to take actions by calling APIs or tools in this case. And some autonomy to decide when and which action to take. This is again a very high level understanding of what AI agents are. So if you ask ChatGPT the cricket score, you'll actually get the correct answer. That's because ChatGPT has built-in tools like browsing, which helps it fetch information the model itself doesn't know. That's a very simple AI agent in action. But things get challenging when you want your AI agent to handle more complex tasks or interact with multiple external systems. Let's say you want to build an AI agent with hotel bookings or for hotel bookings. Now, you want it to fetch hotel availability from booking.com, Airbnb, and Make My Trip, or maybe some other external website. You want it to compare the options, apply filters like must have a balcony or something, or any of these filters like cost, review, and ratings, and finally reserve or book the selected hotels. Each one of these platforms, Booking.com, Airbnb, and Make My Trip, have their own set of APIs, and their APIs have their own structure, different request formats, different response formats, and different authentication methods. Now, to make your agent work with these APIs, your engineering team needs to write glue code for each one. They need to translate these different structures into something that LLMs can understand and reason. And as the number of integration grows, the amount of custom glue code you maintain also grows. This makes your AI agent harder to build, harder to maintain, and much harder to scale. This is the exact problem MCP tries to solve. So MCP, Model Context Protocol, is a standardized way of AI agents to interact with external tools, data sources, and third-party systems. Think of it as shared language or common protocol that both AI agents and external systems agree on. So instead of writing a custom integration for every API, the external system exposes an MCP server, which follows MCP rules or protocols, and your AI application acts as an MCP client. Once the external system exposes the MCP server, the agent can directly see what actions are possible, what inputs are required, what the output will look like, and what it is allowed or not allowed to do. And this removes a large amount of integration work. Now, going back to the hotel example, instead of integrating separately with Booking.com, Airbnb, and Make My Trip, each of these companies can expose their own MCP servers. Your AI agent simply connects as an MCP client and uses these capabilities right away. Now, MCP servers expose three main things. First is the tools. These are actions that the AI agent can perform. Each tool comes with a clear description, well-defined input and output schema, constraints, and safety rules. This helps the LLM understand exactly how to call the tool. Second is prompts. Servers can expose reusable prompts that follow a consistent structure. This helps maintain alignment and reduce the prompt engineering effort. Third is the resources. These represent pieces of data the AI agent can access in standardized format. This makes it easy for LLMs to read and work with information. Together, these make AI to system interactions much more reliable and predictable. So why does this matter for you as a PM? So MCP directly affects how quickly and efficiently you can ship AI integration features. There are some of the practical examples inside your product. One is the CRM use cases where AI agent can fetch, update, and create CRM records without needing separate custom integrations by directly connecting to something like an MCP server of a particular external application, like a Zoho MC. Second use case could be appointment booking. So with an MCP setup of Google Calendar or Salesforce Calendar or could be other calendar applications, your AI agent can check availability, schedule appointments, and send confirmations. Third use case could be payment and billing. Razorpay recently released their own MCP server where they power the use cases of payment flows, invoice details, or checking payment statuses. All of these capabilities can now be integrated very easily through an MCP route to your AI application. Internal tooling cases are also there. So there is Notion MCP, Atlassian MCP. So you can, your agent can talk to systems like Jira, Notion, any of the internal databases or your company's APIs through MCP. And on the other side, you may also want to expose your own MCP server so that external AI applications can easily connect to your system. This can make your product more interoperable, easier to integrate with, and even open up new distribution or partnership opportunities. So in summary, LLMs can generate responses. AI agents combine LLMs with actions. But to make AI agents interact with real world systems safely and consistently, we needed some standard. One of that standard is MCP, which has become very popular. It solves a very real integration problem. And as AI adoption increases, having MCP support will become more and more important. Understanding MCP will help you build better AI features, reduce integration overhead, and stay ahead as AI becomes a core part of modern product development. Thanks for watching this video. Let me know your thoughts in comments, and if this has helped you in any way, don't forget to like the video.